Hello, my name is Blaž Godina and I'm a product manager here in Metrel. I'm responsible for the product group Machines, Appliances and Switchgear Safety, which also includes the new product group for end-of-line safety testing. The purpose of today's webinar is to present the product solutions for end-of-line testing. To begin with, we will first look to what led us to decide entering the field of industrial testing. At this point, we will have a short historical overview. Some of you are familiar with the previous generation product, the MI2094, which had similar design to the new one, but fewer of you are familiar that already previous model has been integrated into several production lines. Due to the fact that we didn't have appropriate optional accessories, the integrators had to improvise a test system integration. Here are just some of the production lines where our test instruments was used. The experiences which we have gathered in the past has been registered and now implemented into new products. The starting point for the design of new product solutions is the European standard EN 5191. In Germany, it is recognized as a DGUV information 203034. According to the EN 5191 standard, there are few options available for execution of test station depending on the safety design. How to select the appropriate test station for your application? The answer lies in the flowchart. Using the product selector table, we can decide which type of test station is most suitable for a particular area. If we are not forced to use test currents higher than 3 mA for HV test, we can omit the requirements from EN 5191. Following the green code in the flowchart will lead us to selection of S2115, test station with current limitation. If we can't avoid to follow requirements from EN 5191, there are still two main options available. Test station with automatic protection against direct contact and test station without automatic protection against direct contact. In the field of test stations with automatic protection against direct contact, Metrel has prepared two solutions. One where safety is assured with a safety module designed in the RFID sensor. It is S2109. And the one when the safety is assured with a safety module designed in the light barrier sensor. This one is S2110. In the field of test station without automatic protection against direct contact, Metrel has prepared a solution on the two-hand control device, and this is S2111. For the better understanding of the upcoming slides equipped with technical data of different components, we will first go separately through the specific components of the available test system. Under the serial number 1, there is located a safety module. This can be module equipped with RFID sensor, light curtain, two-hand control, or safety module with current limitation. All of them are connected to the same connection ports on the instrument and are therefore protecting the operator of test station from electric shock. RFID sensor is monitoring the position of the doors. The test sequence can only be started when the doors are securely closed. The cage-closed RFID sensor is coded. Therefore, malfunction or misuse is practically impossible. The next safety system is equipped with light curtain. The light curtain sensor monitors breaches of the prohibition zone by any object. If the light curtains detect a breach, the safety module will disconnect the measurement circuits from the mains. The two-hand control module prevents the user to perform hazardous tests. The device only allows the test to start when the user has both hands in contact with the safety set. Both buttons on the pair of hand controls must be pressed during the test. This prevents the user from accidentally coming into contact with the parts that become live during the test. The last is the current monitoring sensor. The test station with a current monitoring safety module is intended for production lines where withstanding test can be performed with low current output, so the E-test is below 3 mA. When such test station is used, the requirements of EN 5191 can be omitted. From the other components used in the test system, the connection boxes, which are passive devices that acts as a connection interface between the CE switch and the equipment under tests, and the test cages are the ones that differ from each other the most. The active CE switch adapter is an electric component which has to be used in such test system in order to connect available connection boxes and to enable execution of active, passive and high voltage tests from a test socket. This is only possible due to the robust relays installed inside the CE switch adapter. Remaining components of the system are remote start button and emergency stop button, signalization warning lamp, and rack housing, which is designed to hold the CE multitester instrument, CE switch 5 kV, or in some additional applications even A1460 CE test adapter. A1600. The active CE switch 5 kV is an active multi-channel switch intended to run auto sequences or single tests on electrical equipment in combination with the master test instrument. Testing with high voltages up to 5.1 kV AC or 6 kV DC is supported. The operation of CE switch is completely controlled by the master instrument. Therefore, no user intervention during the tests is needed. Inputs, output connections, and LED connections for controlling the auto sequence flow are integrated. Testing of electrical equipment with multiple connection points is also supported. Different end adapters, or so-called connection boxes, can be connected to the switch. The switch automatically recognizes the connected adapter and prevents applying too high voltages and currents to it. Protection is assured both by hardware and software. On the front panel of the A1600 we can find following: power on indication LED, indication LEDs of lamps outputs, and fuse holders with fuses for protection of L and N test conductors. On the back side of the adapter, we can find following connectors and terminals. The first one is the screw-type protective earth connector for connection of supplementary earthing cable. Then we have mains supply connector with integrated on-off switch and fuses. Industrial plug intended for connection to various connection boxes. Currently we have 3 of them: A1626, A1627 or A1688. Then we have buzzer connector and lamps connector for connection of LED signal towers. RS232 PC connector. This one is used for service purposes only. Then we can find 4 HV outputs. These are 4 channels, and these ports are used for connection to connection boxes. Currently, only one of connection boxes can use all of them, and this is A1688. On the top, we can find HV inputs for connection to HV outputs of the test instrument. input for connection to TC1 connector on the test instrument. This is the multifunctional connector. All leakage measurements, power measurement, insulation resistance, and discharging time measurement are delivered to the CE switch via this multifunctional connector. Connection interface to 4-wire continuity connectors on the test instrument, and a complete output connector array plus input connector array. The safety modules are intended for supervising test setups for safe operation. In general, they prevent generating hazardous voltage or current in case of detected anomaly. We will now check what are the parts of the specific safety module, starting with S2109, which is the safety module with RFID sensor. We will see that all of the safety modules have more or less same elements, starting with main supply connector. So all safety modules have to be mains powered for operating. The second one is coded RFID sensor. This sensor is installed into Metrel test cage, but can also be installed into any third-party test cages. Then we can find remote start, enabling execution of test sequences, or triggering back the emergency system in case of emergency stop was pressed. Of course, we can also find the emergency stop here, and connection cable with connector to be connected on the front panel of the test instrument. Standard set of such safety module is as follows. Each safety module has the safety device, connection cable, main supply cable, and start and stop button. The next one is the S2110, the safety module with safety light curtains. Again, we can find main supply connector, then light curtain sensor. Currently installed sensor has the length of 750 millimeters, and this sensor can also be installed to third-party test cages. Of course, also here, different sensor lengths can be installed. We are supporting the lengths from 14 millimeters up to 3000 millimeters long. That means almost, of course, 3 meters. Again, remote start and emergency stop, and connection cable with connectors to be connected on the front panel of test instrument. And standard set of such module is as following. Light curtain sensors, safety module itself, mains connection cable, start and stop button, and communication cable for connecting to the test instrument. The next one in a row is the safety module with two-hand control. This is the S2111. Here again, main supply connector, then we have two-hand control, and this two-hand control has already integrated also emergency stop button, connection cable with connectors to the front panel of test instrument. But in this case, if we want to use remote start, we can use it, but it has to be connected directly to the 1600, so to the CE switch adapter. In the standard set, however, this start button is delivered alongside with the connection cable for connecting it to a 1600. And then, of course, the safety module itself, two-hand control, and mains connection cable. The last one from the safety modules is the S2115 safety module with HV current limitation. So this one is enabling us to test with test currents below 3 milliamps, meaning that we are on the safe side and we can omit requirements from EN 50191. Also here we can first find the main supply connector. The second one is current monitoring device, then remote start and emergency stop button, connection cable with connector to be connected on the front panel of the test instrument, and high voltage input and output cables. Standard set of such system is following. We have two units which are a part of the safety module, communication cable, crocodile clips, additional high voltage lead, emergency stop and remote start button, and main supply cable. The connection box is a passive device that acts as a connection interface between the CE switch A1600 and the equipment under test. It is intended for connection of various types of appliances to A1600 CE switch. Equipment with supply cords or equipment intended for fixed installation can be tested. The connection boxes are coded to prevent applying a too high test voltage to its outputs. Each type of connection box has unique code identifier, which is important for the possible testing options, including some predefined maximum characteristics, such as maximum withstanding test voltage or maximum current for each continuity measurement that could be applied to tested appliance. Connection boxes are available with different socket configurations, depending on the requirement of a particular country. Contact Metrel for ordering specific version of the test socket. Depending on the installed test socket, different limitation can arise. From the table, it can be seen that different test sockets can withstand different test voltages. For example, type 13 can only withstand test voltage up to 2000 volts AC, whereas Australian test socket can withstand test voltages up to 3000 volts. And unfortunately, the US test socket can only withstand test voltages up to 1.5 kV AC. So the first in a row of connection boxes is connection box A1626. It is intended for connection of various single-phase appliances. Appliances equipped with supply cord or equipment intended for fixed installation can be tested. External test commander for testing of earth continuity or other tests where probe is applicable can be used. The next one in a row is A1627. It is intended for connection of various single-phase and three-phase appliances. But we have to pay attention here. On the three-phase appliances, only passive tests can be executed. So real leakages or power measurements are not supported with this test solution. We can test three-phase appliances equipped with supply cord, single-phase appliances equipped with supply cord, or equipment intended for fixed installation can be connected as well. This connection box, in compared to previous one, enables execution of high voltage test from a separate channel. External test commander for testing of earth continuity or other tests where probe is applicable can be used. The last one from the connection boxes currently available is A1688. It is an universal connection box which enables execution of all supported tests of master instrument. There are no limitations related to high voltage testing. It enables execution of high voltage test via 4 separate channels. Additionally to other connection boxes, it supports 2 channels for earth resistance testing with 4-wire test method. Equipment intended for fixed installation or external test socket can be connected to the probes. External test commander for testing of earth continuity or other tests where probe is applicable can also be used. Checkbox A1625. Checkbox or so-called verification box is an absolute must for every production line. Regular inspections reduce the risk of system malfunctioning and returning incorrect measurement results, which in turn can lead to defective, non-functioning, or even dangerous devices sent to the market. This can lead to recalls and unwanted costs. It is wiser to inspect the test system on a daily basis. A1625 checkbox contains built-in electronic component with reference values to confirm the measuring system operates correctly. It can be used for testing correct functionality of the test system and all standard equipment. The A1625 offers checking for the following instrument functions: continuity of protective bonding, insulation resistance, leakage currents, power measurement, residual voltage or so-called discharging time, and withstanding test, or let's say HV HIPOT test. To verify the complete system, the following connection must be executed. Test cages are designed to guarantee the highest requirements possible for protection against accidental direct contact for the operator. Currently, there are two models of test cages available. One for integration of RFID safety module and the other for integration of light curtain safety module. When you will be checking the prices of different components used in certain safety system, you will quickly find out that the prices of test cages are positioned relatively high. Therefore, I'm constantly mentioning that our safety modules can be installed into any custom-made or third-party test cage. Given the fact that there is infinite range of applications and the infinite number of products that need to be tested, it is usually better to make the test cabinet or test cage locally, which will lead in reducing the cost of such safety system. For completing the integration of the test system, Metrel has designed one large rack cabinet with a mount adapter for the installation of MI3394 CE MultiTesterXS and A1600 CE switch. In the following slides, we will check what kind of communication can be established between Metrel test instrument and external control devices such as computers or PLCs. The best possible solution for establishing remote communication, given the input of work required to set up such a system, is to use a communication protocol called black box. The protocol documentation is available for free. The black box protocol enables a two-way communication intended for controlling an instrument as a black box. The so-called BB protocol is a system of rules that allows a PC as a master to start communication by sending the request command to the instrument, which answers according to the protocol. This enables hands-free operation as the control over the tester is delegated to an automated system. The BB protocol solution is primarily suitable for automated production line testing. The black box protocol is also designed to be used with other PC software engineering tools such as Visual Basic, C++, and LabVIEW, which with some effort can be used to perform remote communications between your computer and test instrument. The protocol enables execution of auto sequences and single tests. On the last pages of this document, you will, of course, also find use cases for execution of both single tests or auto sequences. For testing or presentation purposes, Metrel uses a terminal software. Now I will show how the execution of one of the use cases presented in the document can be performed using Metrel terminal software. Sending the string bb enable equals 1 puts the instrument into black box mode. An instrument returns an answer, be done. In the next step, we will send string bb start single test 96, which will execute the measurement using ID number 96. In our case, this is high voltage measurement. The instrument executes the measurement and returns the answer. In our case, these are parameters, limits, results, and status. If needed, it can be set using extra command that instrument is also returning all intermediate results of specific measurement. For those who are interested for more information, this can be found online. Simply search for Metrel knowledge base, and on the left side under applications and tips, you will find black box information with use cases and all available documentation. Instrument or array of instruments can be connected and controlled via Ethernet, serial, or USB communication ports. For advanced users, Metrel offers also SDK. This is Software Development Kit. SDK is an interface for data communication with Metrel new generation test instruments. The SDK itself is a set of subroutine definitions, protocols, and tools for building application software. It is intended for those who want to develop software using .NET platform and need to interface with Metrel instruments. The SDK includes a set of API calls which makes communication with Metrel instruments simple for the user. It provides a way to manipulate data from instrument using a generic data model and makes available a set of rules for extracting and viewing data. SDK is used by customers who employ Metrel equipment and have their own IT support to enable them to integrate the Metrel SDK solution into their systems and platforms. SDK functionalities. So the SDK has also built-in black box protocol for online communication with the measuring instrument. Measurements can be uploaded or downloaded based on the SDK included database. Auto sequences can be uploaded and downloaded to the test instrument as well. SDK enables access to all measurements of measuring instrument, structure object creation, empty measurement creation, upload of newly created workspace on an instrument, or even export to an XML. All of the key features of our solution have already been shown in the previous slides, but in order to sum them up, they are listed here once again. For the integration of the test instrument into test system, Metrel has designed rack adapters and rack housings. Using black box protocol, it is possible to control test system via external software applications such as Visual Basic, C++, and LabVIEW. Safety modules installed in accordingly designed test cages are protecting the operator of a test station from electric shock. The active C switch A1600 is an active multi-channel switch intended to run auto sequences or single tests on electrical equipment in combination with the master test instrument. Different connection boxes can also be used to cover different applications. The built-in feature of connection boxes is that they are coded to prevent applying a too high test voltage to its inputs. Of course, the test system is supporting continuity testing with 2-wire or 4-wire test method. It supports isolation resistance measurement, high voltage testing with both AC and DC voltages, discharge time measurement, different leakage measurements starting substitute leakage, differential leakage, PE leakage and touch leakage, and functional testing for single-phase appliances. The instrument supports large memory with micro SD card and of course touch screen. All active and passive components presented in the previous slides can be easily integrated into the entire test system. We will now look at what the overall solutions look like in reality, starting with two solutions with automatic protection against direct contact. Test stations built with enclosures such as test cages or hoods are the most commonly implemented option. This type of test station is typical in serial production lines, but is also preferred in workshops, repair and service shops. Test station with automatic protection against direct contact may be operated without the control and supervision of a skilled person. Test station using enclosures such as test cages without doors is the preferred solution for production with very high frequency of testing. The safety of such system is assured with a light barrier sensor. Next one is the solution without automatic protection against direct contact. Test station built with a two-hand control safety system is the preferred solution for testing larger objects. When checking the electrical safety of larger electrical devices, PE continuity must be tested on all accessible metal parts. In practice, this means checking the connection of multiple locations on the device. The operator must therefore have access to the device under test at some stage during the electrical safety check to perform the test on every test point. The main job of the two-hand safety device at this type of safety station is to prevent the user from performing hazardous tests when exposed to the risk of electric shock. Test installation where EN 5191 can be omitted. Ensuring safety at work is a requirement of the Association for Employers' Liability Insurance. Safety requirements for execution of high voltage tests are defined in the standard EN 5191. Test stations with a current monitoring safety module are intended for production lines where withstanding tests can be performed with low current outputs, under 3 mA. When such test station is used, the requirements of the standard can be omitted. The operator initiates the test sequence using the external start key. Despite the fact that safety is ensured by the current limit, the test station is additionally protected by a safety button for emergency shutdown. In the following slides, we will check what kind of marketing materials are prepared for this product group. On the Metrel website, there are two entry points to reach materials related to end-of-line product group. The general entry point is accessible via tab Products, and additional entry point Solutions accessible for the registered users only and available when you are logged in. Both websites offer a lot of information related to end-of-line solutions. For the needs of promoting industrial solutions, we also prepared two documents. A practical guide for erection and operation of electrical test equipment according to EN 5191. This guide covers a basic introduction to electrical safety and an overview of the EN 5191 standard. The test diagrams presented are designed as a guideline for people involved in testing on production lines equipped with CE MultiTesterXS. And the other one is the solution for electrical safety test systems. This brochure contains a mix of technical and application data, including pictures and connection diagrams of complete systems. This would be all from my side. Now we are ready for questions. Thank you.